Hi, geometry students. These notes are on proving lines parallel. Before now, we looked at some theorems that said, like, if we know two lines are parallel, then we know certain angles to be congruent. So I'm gonna introduce some new theorems today, which are basically going in the opposite direction. So this is called like the converse of the previous theorems. Okay, so these first three theorems here, under theorems to prove lines parallel, are all the converses of theorems or postulates you already have in your notes. So it's basically just going in the opposite direction. So we're going to run through this briefly, and they should be they should make a lot of sense because the first three should be familiar. However, we're going to put in the short forms for each and just kind of take a look at the diagrams. But the idea for the first one, it says, if alternate interior angles are congruent, then we know two lines are parallel. So like in this picture, if we were given that those two angles were congruent, the idea is we could conclude that line A is parallel to line B. And the short form would be something like alt int angles congruent. And then I'm going to do like the little arrow to symbolize then. And then I'm going to write lines parallel. Okay, so those two vertical lines next to each other mean parallel. The next one, if alternate exterior angles are congruent, then it's the same idea. Then we also know the lines are parallel. And again, if we look at this picture, if we were given that, say, this angle up here and this angle down here were congruent, then this theorem says we would know for sure at that point that this line is parallel to this line. My short form is going to be similar to my last short form. It's going to say, instead of alt int this time, I'll say alt ext angles congruent, then, putting the arrow to mean then, lines parallel. And the last of these first three theorems is if corresponding angles are congruent, then the lines are parallel. So those two angles are corresponding, so we'd say corresponding angles congruent, then lines are parallel. Okay, so when you're eventually in next class, we're going to be practicing these proofs. So your reasons, instead of writing out the entire proof, can be these little short forms. Okay, so this is a quick practice. So if you read it, it says, do lines A and B have to be parallel? If so, which theorem supports your conclusion? The idea is you're trying to match each of these pictures to one of these theorems. So if you think the theorem applies, you're writing the short form of that theorem underneath the letter. Excuse me. Okay, now there's two new types of angle pair relationships that we're going to learn about in this video. The first one is the ones in this picture. Angles 1 and 2 represent the first new pair that has a name. So it says, first of all, it says the angles in the diagram below are called, so these are called same side interior. Angles. Okay, so the idea is they're both on the interior of the two lines, and in the sense that they're both in between these two lines, right? This is the interior. And they're on the same side of the transversal. So if this is the transversal here, they're both on the right side of that transversal. So now the next thing it says is, what do you notice or wonder about the relationship between these two angles? So if you want, you can pause the video right here and think for a moment about what we might be able to say about these two angles, and then I'm about to go on and explain it. So we're going to fill in the theorem with what we notice to be the relationship. One thing you might have noticed would be like I would know like angle 1 is congruent to the angle down here because these are corresponding, and I know this angle down here is supplementary to angle 2. So by the congruent supplement theorem, I could conclude that like angle 1 is supplementary to angle 2 since 1 is congruent to the supplement of 2. This leads us to a new theorem. If lines are parallel, then same side interior angles are supplementary. And my short form would be lines parallel, then same side int angles are supplementary. So this one doesn't abbreviate quite as nicely because there's no symbol that means supplementary. And then the second theorem, this is the converse of the first. Okay, so this is what I was mentioning about going in the opposite direction. It says if same side interior angles are supplementary, then since it's the converse, it's basically like the reverse of this theorem, right? So we're starting with the then statement here. So our conclusion should be the if statement. So then we would know the lines are parallel. And our short form is basically just the reverse of the short form there. So it'd say same side interior angles supplementary, then lines parallel. Okay, so we have these two new theorems. Now, I'm going to throw a couple more theorems your way, and this is going to kind of wrap up all the theorems for the time being. But what I want to stress to you is that these theorems are basically, they all have a similar structure, so it's just kind of like keeping in your head what are all the different angle pair relationships and what's the relationships there. So these ones are going to be similar to what we just did. So before we were looking at like these two angles, right? We had 1 and 2 here. Now we're looking at 1 and 7. This pair is called same side exterior angles. Okay, so the angles in the diagram below are called same side exterior angles. What do you notice or wonder about them? So you could take a moment if you want to pause the video and think about what we might be able to say the relationship is between those two angles. And now I'm going to keep going, but you could pause right then. The theorem states if lines are parallel, then same side exterior angles are, this is going to be exactly the same as same side interior. If you can think about like if these two were supplementary, right? So are these two. Okay? So we have same side exterior angles are supplementary. What's my short form? We have lines parallel, then same side exterior. Oh, I forgot to abbreviate exterior, but I would just do like EXD. Sorry. Same side exterior angles supplementary. Okay, and then we have the converse of the theorem. The converse, which says if same side interior angles are supplementary, then the lines are parallel. And my short form would be, I'd write same side exterior first. Supplementary. That leads me to conclude the lines parallel. And my last theorem, one more theorem. Okay, this one's kind of random and by itself. It says if two coplanar lines are perpendicular to a third line, then they are parallel. So the idea would be, let me draw you a quick picture. If I have some line here, and then I have two other lines that are both, that intersect this line and are both parallel to it. Or sorry, are both perpendicular to it. And coplanar basically just means like on the same plane, so basically on the same two-dimensional space. So my piece of paper is like them being coplanar. So I could draw one kind of line segment like that, and the idea is I'm telling you those two are perpendicular. And then I'm drawing another one that's also perpendicular. The idea is that the red line and the purple line are parallel to each other if they're both perpendicular to the blue line. And that should make some sense if you just think about the visual there. So the rest of this is going to be looking at some examples of how can we look at a diagram and try to recognize what theorem we'll need to use, okay? And part of it is, like, if you're trying to prove something is parallel, then you need to make sure you're using a theorem that in which the conclusion is that lines are parallel, right? We're using one of those theorems and not its converse. Okay, so I'm going to do some of these for you, and then I'm going to have you do some of them as the U-tries. I'm going to do the first one in 2A. This one I'll do. So it says, are lines C and D parallel? If so, which theorem would you use to prove it? So if I'm looking at the first one, A, I'm looking at the two given angles, and I see that one's 100 and one is 80. So what I immediately notice is that those two are supplementary, right? 100 plus 80 equals 180. These are supplementary, right? So the idea would then be which theorem, first of all, which theorem is going to help me say if they're parallel or not? Well, I have to recognize that these are same side exterior angles, right? It looks like this, except it's on the other side of the picture, of the transversal, right? So what are our theorems? We have to use one of these two theorems of the same side exterior angles. So the idea is it's the second one, because I'm given same side exterior angles are supplementary, and I'm going to be able to conclude that the lines are parallel. So to answer the question then, I would say, yes, C is parallel to D, and then my reason, the theorem, I would just write the theorem. So I would write same side exterior angles supplementary, put my arrow, and then write lines parallel. Okay, so I want you to do for the U-tries B and C here. Okay, and remember that there are theorems right above these problems on this page, but there are also some theorems on the first page. So for some of these, you might want to flip back and read through the other theorems as well and see if some of those might help you. Okay, so in the second chunk of practice problems, it says we're trying to decide if given like one set of information, can we say which lines will be parallel in the diagram and which theorem justifies that? Okay, so a hint is that we can highlight angles to help you find the transversal and the parallel lines. So in number 3, I'm going to do number 3 and let you try number 4, but in number 3 it says we have angle 1 is congruent to angle 2, and we're trying to figure out which lines are parallel. So if I can't immediately see which lines are parallel, it's either these two, right, P, Q, and RS, or it's these two, just based on like visually which ones look parallel. And I need to be able to use the two angles I know to be congruent. So what I'm going to do is kind of like trace the segments that make up those angles. So do we see how these are all the segments that form the two angles, right? These two segments form angle 1, and these two segments form angle 2. So now that I have that drawn out, I might be able to tell that I have these two lines cut by this transversal, and angle 1 and angle 2 are alternate interior, right? And if I really can't see that yet, then I could extend the lines as well, and that might help you see what's going on. Okay, so then which two lines are parallel? PQ is since they asked for lines, I'm going to use the line notation with the arrows. PQ is parallel to SR. And how do I know? Because, and I have to think, like, which direction do I need the theorem? I need if alternate interior angles are congruent, then the lines are parallel. So I say alt int angles congruent, then, I'm using my arrow to mean then, lines parallel. Okay, so I'm going to have you do that for number 4. If you want, you can pause the video and try right now. I'm going to do one more example, and that might help you with this, so you could also just wait till the very end to do this U-try problem. So I'm going to flip to the next page now. I'm going to have number 5 be a U-try problem, and I'm going to do number 6. So let's all look at number 6 together, and then you can go back and do number 5. And starting with proof practice, don't worry about anything after here. We're going to work on that in class. Okay, so we'll be working on this in class. So let's look at number 6 together. It says if angles 1 and angle 2 are congruent. Write a theorem, then which two lines are parallel? Write a theorem that justifies your answer. Now I wanted to do this one as all together because I think this one is especially difficult to see where the two parallel lines are. And I'm going to give you my same strategy as before, which is let's trace the segments that create each angle. So like BE and AE create that angle 1, and then FD and FC create angle 2. Now, the way I have outlined it, I don't see a parallel cut by a transversal, but what I do see is like segment AE and segment FC all fall on the same line. So I'm actually going to do a little bit more and highlight that. And now I'm wondering, can you see what's going on here and where the two parallel lines are? It actually has nothing to do with any of the outer edges of the shape, but has to do with the fact that like I have lines here and here, right? And then I have a transversal going through them. So I want you guys to think for a moment about what's the angle pair relationship between these two angles right here, between angle 1 and angle 2. And if you think they're on the opposite sides of the transversal, they're on the exterior of the two lines. So these are alternate exterior angles, right? And we know that they are congruent. So then we can say that these two lines are parallel because we have alternate exterior angles congruent. So I would say BE is parallel to FD, and my reason would be alternate exterior angles congruent, then the lines are parallel. Okay, so do the best that you can, and certainly we're going to be practicing this more in class, but you're trying this try problem, and then on this page you're trying number 4 down here, and if you didn't already, you're trying B and C over here.